Hello guys, welcome to my channel. In this lesson, we are going to learn how to simplify the powers of I. All right, let's get started. But before we move on to anything, we would know that I represents the square root of -1. So because we're working with complex numbers, okay? All right, so I represent the square root of -1. So let's get started by increasing the exponent of I to the second power. So what we mean here is when we say powers, we have to realize that just means exponents of I. Okay. All right. Sometimes we can use index. We can say index. Okay. Or indices. That's a plural form of index. Okay. All right, so sometimes you have these words together and they mean the same thing. All right, let's start from maybe let's talk about I to the second power. To do I to the second power, we will just notice that I represents the square root of -1, right? So and then we will just take that to the second power, which is the square of that. And now we know the square root and the square are opposite of each other, so they will just cross each other out, and then you get -1. So that's why we always say that I to the second power is -1. All right, let's go ahead and do another one. Let's take I to the third power, for example. So for I to the third power, what I'm going to do here is decompose I to what? I to the squared and I to the 1. Because we know that I to the third power means I times what? Times I. So three of them together like that. So this 2 here gives I to the second power, and I'm just multiplying that by I, which gives I to the third power. So we have already found out that I to the squared is -1, and I just throw in I, and that means -I. So this is where we can stop here. So that means I to the third power means -I. Let's increase a little bit to I to the fourth. I to the fourth will mean I times I times I times I, right? And I'm just going to group these two together. So I times I is I to the second power, and I times I is also I to the second power. So in this case, we're just looking at I to the second power is -1, and we'll just multiply it by another I to the second power, which is also -1, and then we get +1. So, so which means that we're going to take note that I to what? To second power is -1, while I to the fourth power is equal to 1. So these two facts will help you solve any problem involving the exponents of I. So meaning that I'm now looking to, for example, if I'm looking to solve I to the 8th power, so let's go and, maybe do start with I to the 6th power. So let's do I to the 6th power. For I to the 6th power, what I'm going to do here is to to the 6th power is to write I to the 6th as I to the 4th times I to the second power. Notice what I'm doing here, right? Because I, then an I times I, which is going to be I to the 6th power. So what I'm going to do here is, because I already know I to the 4th power is 1, I'll just substitute that. Okay, and then I'll multiply by I to the second power, which is -1, and I'll just multiply these two results together to get the power. All right, which means I end up with -1. So which means that I to the 6th power will always represent -1. So, and then you can see patterns here. So let's do I to the 7th power. For I to the 7th power, what I'm going to do here is I'm going to decompose I to the 7th power as I to the 4th power times I to the second power times I. So you can see that you have 4 plus 2 plus 1, and all of that will give 7. Yes, so from here, I know that I to the 4th power is 1 times I to the second power is -1, and I just multiply by I because that's all I get. So which means 1 times -1 times I. Again, that will give what? -I. So you can see that I to the 7th power is given -I. All right, we go to another example where we're doing I to the 8th power. For I to the 8th power, it will mean I to the 4th times I to the 4th. And I to the 4th is 1, and I to the 4th is also 1. That means 1 times 1 is what? 1. So I to the 8th power is 1. So from this pattern, you can see that you can see what is happening. So it looks like when we have multiples of 4, if we have powers or exponents that are multiples of 4, it always gives 1, right? You can see that. And then if we have exponents that are only multiples of 2 and not multiples of 4, we'll get -1. You see? So that's what I'm noticing. So even here, you can see that if they're just multiples of 2 and they're not multiples of 4, it will be -1. Again, when the exponents are odd, because when we did I to the third power, so if I just squeeze in I to the third power here, you see that gave us what? -I. Cool. And then you're seeing that when we're having that to the odd number, we're getting -I. So let's look at, but then I to the fifth power might be a little different. So let's look at I to the fifth power. So for I to the fifth power, what that gives me is I to the fourth power times I to the power 1. So which just gives me I to the fourth power. We know that's 1 times I. So 1 times I is just I. This is a little different now. So when you have I to the fifth power, you get I. So which means that having I to the seventh power and having I to the fifth power would be very different. So when the powers are odd, you have to be a little very careful. You have to be very careful, okay? Like, hey, if you're doing like I, let's do another one. Like I to the maybe to the 11th power and I to the 13th power and so on. So let's do I to 11th power for I to 11th power. So what we got would be I to the fourth. So I'm now breaking to I to the fourth times I to the fourth. That means 4 plus 4 is already 8 times I to the third. So I know that I to the third will be I to the second and I to the 1. So this is what I'm doing so that I can have 4 plus 4 plus 2 plus 1. And all of that would give 13. Yes? Okay, so I will give 11, not 13. So I'm looking at 11 now. So 4 plus 4 plus 2 plus 1, that would be 11. Yes, so I know that I to the fourth will be 1 times I to the fourth will be 1 times I to the second will be -1, and I to the 1 is just I. Cool. All right, so when I multiply all these numbers, I get -I. You see what I'm getting now? So when you have odd numbers, it will just alternate between I and -I. So if we did I to the ninth power, you see that this is going to give us I to the eighth power times I. Now I'm doing 8 power because I know that, 8 plus 1 is 9. So I just do 8 power because I know 8 power here gives 1. So that just means 1 times I, which is I. So you can see what is happening. So when the power is odd, it would alternate between -I and +I. But then there's a way you can come up with something to be able to kind of, quickly determine uh, what you're getting when the powers are odd and when the powers are even. So let's do one big one. So let's say we're looking for the exponent. Let's say number 9 problem, looking for the exponent or the I to the 1002, something like that. As high as that. Okay, so as high as that, that would give you like, hey, I'm gonna do it as I to the what? 1000 times I to the second power because this is 1002. And I know that this exponent 1000 is divisible by 4. So if the exponent is divisible by 4, it will just go to 1. Okay, so that means I to the 1000 will exactly be 1. And I know that I to second power will just be -1, right? So it will be -1. So which means that I to 1002 will give me -1. You see, this is because 1002 is not divisible by 4 exactly. So if it's just an even number and it's not divisible by 4, your final answer will always be -1. All right, so there are other interesting cases where you can have negative exponents. So it's the same strategy. For example, if I throw in one where I say calculate I to the -12, something like that. So, and we know that negative exponents means the reciprocal of something. So that means you're looking at 1 over I to the 12th, right? So we know that I to the 12th power, and 12th power is divisible by 4, and that would just be 1 over 1, which is going to be what? 1. So these are other situations too. Like maybe let's do maybe I to, let's call this one number 11 here. I'm just doing random stuff. So let's talk about maybe I to -5. Okay. To do I to -5, that would just mean 1 over I to the 5th power. All right. And we just found out that I to the 5th power right here, when we did I to the 5th power, we found out that I to the 5th power, number 7 here, will be I. Okay, so that means we're going to have 1 over I. Now, 1 over I, so we have to, work on the denominator. So you want to make sure that your denominator is not imaginary. So one trick that you can use here is to multiply it to itself. So you multiply, you make it rational. So what you're going to do here is multiply both the numerator and the denominator by I. So you would be 1 over I times itself. And then you also have to go up and to the numerator and do the same so that you don't you have an equivalent fraction. All right. Okay. So 1 times I will be I divided by, that I times I is -1, so that will be -1. So which means your final result is just -I, because when you do I divide by -1, and that will just mean -I. I hope you can see that. I was just trying to manage my space. All right, so this is how you can deal with problems like this one. So if I'm doing for example, say I to -7. Yes. So let's do I to -7. Let me see. So I'm gonna just use this space here. I to -7. So I to -7 would mean 1 over I to the 7th power, isn't it? And then if we do this, we get 1 over, because we already did number 5 is actually I to the 7th power. So which means I'm going to have to replace the denominator, which is I to the 7th power, by -I, right? -I. So, and that's how it's looking like. Now, in order to simplify, I will just multiply the denominator by I again, or I can multiply by -I, depending on what I'm looking at. So I can just multiply the denominator by I. So it will now be 1 times I divided by -I times I. So I'm multiplying the denominator by I and also making sure I'm multiplying the numerator by I, so that the fraction would remain, it would look like it remains, I mean, the quotient would remain equivalent. So now 1 times I is just I divided by -I times I will be -I to the squared. And then we know that I to the squared is -1. So which means if we have -I to the squared, it will just give us I divided by negative of -1, because we know that I to the squared is -1. So again, all of these results will end up being what? I. You can see the difference. So I to the -7th power will give us I, whereas I to the -5th power that we saw here will give us -I. So we're just comparing these results. All right, so this is how far we can go about the powers of I. I hope this is a little helpful, and stay tuned, and I will see you in another class.